screen. Uh,
Yes, sir.
okay, so we'll quickly start with things, then we'll come to algorithms and approaches. First question everybody has is like, what is malware? As you all know, like today, when you are trying to access any systems, let's take you're running a program or you are trying to access a mail or you are trying to have some sort of analysis applications running. Suddenly you get a message saying that the system is attacked. There is a possibility that you have a malicious computer executable that is running on your system. So that's called as a malware. So malware as such will be very much dangerous
Excuse me, sir.
because, yeah, ma'am,
Now screen is not visible, sir.
not visible. Okay.
No.
Well, I've shared. Is it visible?
No, sir. You are sharing the desktop only, no, sir? Like
Yeah, I'm sharing
screen.
desktop, ma'am.
Oh, okay. We are not able to see.
Wait, ma'am, I'll do it again.
Yeah, yeah.
You are able to see the screen?
No. Now we
Hello?
can see, sir. Yeah, now I
Okay,
can
right,
see.
right, ma'am. Right. Okay, fine. 1 second.
Hmm.
Okay, so let's start our discussions. So the first question somebody would be interested to know is what is a malware and how it is very much important in understanding with respect to the safety of a system. Malware is called as a malicious program that can come as part of an application. Let's take you work with a mail or let's take you're working with a process. There is a possibility that a malware can land into your computer. So what is the reason for increase in malware? That's the next question somebody would ask. Reason is we are all going with the dependency of computers. And I think recently you would have seen that the time after COVID has started, we are facing problems that we are not able to have security as part of systems. So if you talk about any companies today, there is a growing need for security. Reason is people have started moving to the desktops at home, and there's a lot of possibility that the systems as such is not able to secure themselves in their own way, right? So the next difficulty here is like the challenges that the users experience is also very hard. For example, the user wants to say, I have secured my system. You say, I've installed an antivirus software, and then you install one more program software for securing a system. Still, the challenge lies there because the safety and security is not in place, right? Now, let's go into understand the top 10 malware that is generally there. This is the top 10 malwares that are listed in the internet community. So you happen to have your system with any of these malwares, there's a lot of issues because your system is not secured. So let's come to the types of malware. Malwares are categorized like this. They're categorized as virus and worms, spyware and adware. Then they are categorized as bots, trojans, and next is keyloggers. So under this, the type of attacks that you get is backdoors and DOS attacks. Now let's come to the virus and worms, right? So as far as virus and worms are concerned, worms are the oldest one. So the first one worm is worm, and virus as such always requires systems to run with a particular application. For example, if you open a Word document, there's a possibility that a virus can come to your computer. Both the virus and worm can actually start spreading through the email, right? So people have been more worried about in accessing emails. That is the only reason today we have a folder called as spam in all the mail accounts, right? The spam as such filters the mails, but most common sometimes what happens is there is a possibility that the spam will again try to show mails which are incorrect mails. So we have to use our human intelligence mails part and say that this is a correct mail or a incorrect mail that carries a virus or a worm, right? So next one for our discussion would be is understanding with respect to the spywares and adwares. So as far as spywares and adwares, they don't spread like virus, but instead they come as part of a peer-to-peer programs. So you have installed a software, there's a possibility for a spyware to come. So the spyware as such will try to take some data from your computer and try to steal the information back to the end user. There is the end user means somebody is the owner of your application or your system rather than you. The next one is the bots and trojans. Bots as such will infect multiple computers, right? But trojans as such will try to have a small piece of malware in a system. So example, it could be an adware or a keylogger, right? Keylogger, each one of you know, you are typing something in the password of your mail account. There's a possibility that somebody is trying to steal your password, right? So this takes you to the understanding saying that your system as such can actually have a lot of difficulties because of this malwares. What are the difficulties? First one is difficulty with respect to homogeneous part. That means if you have computers running the same operating system, then it is possible for somebody to access your computer and try to attack it also, right? Second is as far as the defects are concerned, the defects can be learned by the malware. For example, like a malware can actually come to your system, get it installed. Later, you install an antivirus. It can understand that this antivirus can actually handle only this type of signatures. So whatever I am trying to create, right, will be not found by the antivirus software, right? The next one is the possibility that there is a code and the code as such will be running because you are not running, but it automatically runs, right? The next categories are with respect to the users and code. Sometimes what happens is the users as such will try to access themselves as admins. So when you are as admin and somebody can access your admin password as an hacker, then they will be able to get control of your system either by providing a malware or they might try to land in with some sort of virus, right? Let's come to the next part of what a virus would be is like. So virus as such is a piece of code which can be infecting other programs, right? So it actually leads into possibilities that it can affect other computers also as part of the network, right? A virus as such is specific to particular software or hardware platform, right? Next comes the lifetime of the virus, right? Lifetime of the virus can be categorized into four categories. First category is called as dormant phase. Second category is propagation phase. Third is triggering phase. Fourth is execution phase. Dormant phase as such, it means that the virus as such will be part of your system, right? So it is possible that it is not able to execute itself all the time, right? It means that it is idle. Second is propagation phase. What is propagation phase? Is a virus as such will copy itself into some other programs. Like now it's coming into Word. Let's take it is coming from Word, then it might go into Excel. It might go into some other application that you have installed in your system. The third one is triggering phase. Triggering phase as such is activated as part of a system event, right? So let's take your system is having an event by default, it triggers a virus, right? Last one is execution phase. Execution phase as such is part of any malicious programs that is going to happen in your system. So this is a part of a virus structure code, right? If you can see in this virus structure code, it carries a keyword saying program, and in this you have a main section, and there's an executable file, right? So what happens is whenever there is a part of code like this which starts executing, it might try to trigger an executable file, right? And that executable file can carry something with respect to the virus. So that's where you can see that your Word is running, your Word document is there, but still there is a virus to the Word document. The virus to the Word document is part of the executable file that is getting attached to it. These are the types of virus that are generally there, right? One is called as parasitic virus, which is basically a normal type of virus. Next is memory resident virus. Basically, what it does is it locates in the memory and infects all the executing programs, right? The next is boot sector virus. What is this boot sector virus? Is whenever the system is getting booted, right, the virus will start spreading. Next is a stealth virus. What is the stealth virus? This is basically with respect to the input or output operation, which the user does with the system. For example, you put a pen drive, you put a CD drive, automatically the virus is coming to your system. Next is polymorphic virus. Polymorphic virus as such is means, as the name indicates, it is basically multiplicative part, right? So it looks at the signatures and analyze whether there is an error in your program or not. And if there is an error in the program, automatically it tries to add its own signature and make a virus as part of the program itself, right? Next is metamorphic virus. Metamorphic virus is also similar to polymorphic virus. Only thing is it will start changing its behavior over the course of time. So email virus is what everybody knows. We know that when a person is trying to send a mail with a Word document, there is always a possibility that the mail will carry a virus also together. When you download the system, what happens is it will try to show you that there is an error, right? And the error as such can be taken for understanding the type of virus, right? Now people are talking about lot of antivirus applications, right? The antivirus applications as such are there, but still no system is complete, right? So system as such has to be made powerful. So if you have to make it powerful, then you can make the system to understand that this is a type of error and this is a type of virus that is coming up, right? Okay. So in this process, what people talk about is something called as handling the virus by looking at a signature part, right? So signatures are very important in any application, right? Signatures can be provided as part of any application to understand that there is a virus or there is a malware or whether there is some infectious program to that is happening in the system, right? Okay. Now in this line, what we have is something called as grayware. So what is grayware is like graywares as such will be applications that are installed on a human's computer, right? And they will track certain information back to an external source, right? Now, usually it is installed and it is run without the permission of the user. So it is sometimes it is undesirable also, right? The reason is like you know that you have a program, but you don't know that the program is stealing some data from the system, right? Okay, so next is a Trojan horse. Trojan horse is another way of looking into the software, right? Trojan horse as such is again will perform an action which is similar to a virus. It will always carry a payload also, right? Okay. This is the first introduction that I want to talk to you with respect to malwares. Any questions at this point about the introduction to malware? Any questions at this point regarding introduction to malware? Participants, if you have any questions, please put in the chat box. Hello. Hello. Any questions?
Sir, I think there is no questions.
There's no questions. Okay. Now, this is the next point for us to understand that we have to look at possibilities of understanding signatures. Okay. So, signatures means it is basically carrying some information about the malware. So, let's look at a small point of understanding, okay, how a signature will look like. So, a data set that is carrying signatures will represent all the information in form of features, right? So let's go to an Excel sheet to start understanding about features and the importance of features in categorizing the malwares, right? So now this is a template of an Excel sheet. Ma'am, can you see the screen, madam?
Yes, sir.
Okay, right. So if you look at a malware, the malware will also carry some features, and the features can be provided as part of a sheet, right? So you, what is understandable right now is we have extracting features, right? And the features can be populated to the data sheet. So what might happen is you will get n number of features for understanding malware. So what is the name of the feature? All that it depends from one malware to another malware, right? It depends, right? Now, given a set of features, now our question is like we want to associate it to the respective class, right? So each feature as such is a meaningful information with respect to the malware. Now everybody would get a question, okay, is there anything like this on the internet where I can find malware information? Yes. If you go to the internet and type malware data sets, right? Okay, Kaggle, you'll get a data set from Kaggle, which will have the data set for categorizing the malwares, right? Okay. So Malwares are part of applications everywhere, and there is a lot of requirement that you have to categorize malware. So this is not complete data. You maybe next day when you look in, you might try to find a new data set which is relevant to malwares also, right? But this is one data set which I would like to show, right? The other data set that is relevant, which people can use from the research community, is there is a data set from IoT, related to IoT, which you can go and search. You go and see IoT botnet dataset. You go and type IoT botnet dataset, right? You will get dataset relevant to IoT botnet. This is also a good example of malwares, right? This is a very challenging dataset because you'll get a lot of category of attacks, and the attacks as such can be categorized based on the type of information, right? Now, when you look at this data set, IoT botnet data set, as you can see here, what they try to show you is a testbed that they have categorized for IoT botnet data set. So if you look at this testbed, you can see a set of systems, right? And systems as such will categorize themselves into their individual IPs. Now, each one of you will ask a question like, how is this IPs associated with each other, right? Now, all these IPs are part of the same network, or IPs can have their IP address from subnetworks, right? For example, like if you talk about your campus network, each one of you getting connected to your system can have an IP which is part of your network, or it can be part of your bigger network also, right? Okay. Now, let's go forward to start understanding, okay, how can you categorize these features? Now, once the data set is downloaded, you can start categorizing the features. You can find the data set details here. You can find the dataset details here. So you can actually start downloading the dataset. It's very easy. Once you click on it, you'll be able to get the dataset details from here, right? Okay. This dataset as such will have its type. It can be a PCAP file, GO file, Argus file, CSV files, all that, right? So now at this point, people might ask me a question, okay, what is PCAP that you're trying to show it in front of me? PCAP file is as such is a packet trace file. So when you go to go to internet and search for this keyword, something called as packet trace, right? So you will get details about what a packet trace is, right? So what is a packet trace? Packet trace as such is basically one set of packets information corresponding to systems or subsystems in the network, right? For example, let's take I go to my command prompt, okay? I go to my command prompt and I just say ping localhost, right? So what happens is now it's trying to get connected to my system, and naturally it is trying to send a request, right? Okay, so if it is happening successfully, then it might try to say that yes, it is successfully running. You can see here, right? Okay, now the packets are such that are captured, right, will be shared as part of your log, and that log is one example that I'm showing you in this botnet data set. Is it okay, right? So this botnet data set will give you more details about the type of attack. So request everybody to make a note of this data set and use it in case you want to do it in your research part, right? Okay. Now, all this is done. Now let's move on to the next part, right? Next part is like given a set of features that we have with us, we are interested in classifying the data to a respective class. So what is your class that you want to provide is your nature, right? For example, if you start categorizing your data set and start saying that there is an attack, right? You can start classifying the attack as attack 1, 2, 3 like that. So in this case, your answer is like you are trying to categorize your data into three classes. Class 1 is attack 1, class 2 is attack 2, class 3 is attack 3, right? So now once you have captured your features, right? So let's take your features are like this. Once you have captured your features, right? Your features are like this, then automatically the next discussion would be like, how do I categorize my attacks? So your attacks as such will correspond to the respective class. So given a data set like this, given a set of rows, I'm interested in taking one particular row and categorize a type of attack. So the attack type will be, let's take one for an example. The attack type will be one. Next you are saying the attack type is two. Now if you understand about your log, you will say that I have three rows, and out of three rows, two rows are classified as attack type 1 and one row is classified as attack type as 2, right? So when you want to do like this takes you to the bottom line question saying that I might have a data set where there is no class label. How will I put my class label for the data set, right? There you are advantage would be is like you can make use of the algorithms that are there on the models. So one category of algorithms which people know, it is called as unsupervised learning. What is unsupervised learning? If you have a data set where there's no class label for the data set, then in that case what you can do is you can try to provide the class label by using an algorithm from unsupervised. So here example of an algorithm is a k-means algorithm, right? Okay. So if you run a k-means algorithm on the data set, it will try to give you a class label. It might give you class labels as 1 to 1 like that, right? Now, what is this k-means is? K-means as such will give you a value of k. K corresponds to the class. So if you say two classes, then there is possibilities for you to have two classes. That is class 1, class 2, right? Okay. If you say three classes, there is possibility for you to have three classes, class 1, class 2, and third is class 3, right? So given data set for you, and the challenge is now right now is how do you classify your log, right? One second, I'm opening a code. I'm getting one question from the participant. What is your question, sir? How do we know that the Trojan horse malware is in our system and how to do it, right? Okay. See, most of the softwares for recognizing malwares, what they do is they understand with respect to signatures, right? You will have to look at the signature of the malware. Based on it, you can recognize. Is the question answerable, sir? Hello, hello, Vikas Jain, sir. Have you got the answer for the question?
Sir, participants cannot talk. They can put in the chat only.
Yeah, Vikas Jain, sir. I'll try to go slow. Fine. Now, this next point here is like I have features. I'm interested in classifying the features. How do I do with the models, right? So there are a lot of models in the internet for discussion. One is if you don't have a class label for the data, you can find the class label by using an unsupervised algorithm. Example of an unsupervised algorithm is a k-means clustering, right? So here K corresponds to the class label. So if you say two classes, you will get two class label values appearing here. So am I okay? Because hello.
Yes, sir.
Yeah, no, I'm waiting for a response from Vikas sir. Okay, fine.
Sir, others, you can talk. You can unmute and talk, all of you. The permission is given.
Okay, fine, sir, fine. I think we'll go with the things now.
Okay.
Right. Um,
Yes, sir. Yes.
okay,
Hello.
thank you, sir. Thank you. Um, Now, the next question before us is like, how do you classify your data? You can run an unsupervised algorithm and you can classify your data, right? So here, when you're going for a k means, if given a value of k, it will associate with its particular class label. Now, this data that you have classified, right? What happens is this data becomes something called as a training data here, right? Now, the next question is, now once you have got a class label, then you can give a test data, and that test data also will have some features, right? So you will have some features like this for the test data, right? So this is example of feature for your test data. Now what you want to do is you want to run through an algorithm. The algorithm that you can try to run would be an algorithm from a supervised model. So example of an algorithm would be a k nearest neighbor algorithm. So once you run through the algorithm, what happens is it will try to take this test data and compare with the training data that it is already having, and it will try to create its own class. So here the class it will try to create would be either class values as 1 or class values as 2, right? Now suppose you get a data like this. Let's take your data is like this. Let's take 23, 33, 22, 45, right? But it's not able to correspond it to a respective class. Then that case, what is possible is like you can try to understand that this is not a regular data. This data as such falls into something called as an outlier here, right? So now the understanding is if you get a data which is falling outside the regular log in the sense it cannot be classified at all. There you can classify the data to be something called as outliers here, right? Outliers are very important for every problems. Reason is like the more the number of outliers you find in the problem, the better your algorithm classification will be, right? Okay. So now the question is like given a data with us and given a log that we want to classify, what is the appropriate algorithm can I choose? Can I go for k means knn or can I go for some other algorithms? Here there are many discussions here. One possibility is like you can go with something called as a support vector machine, right? So what would support vector machine will give you is support vector machine will give you an approach which is a kernel based approach, right? So right? Support vector machine is giving you something called as a kernel-based approach. So the advantage of kernel-based approach is most of the problems can be solved as a regression problem. That means you can solve it by using a line equation, which could be called as y equal to mx plus c, right? Plus error. But sometimes what happens is it is not possible to just classify my data with a regression problem. There we can go for something with kernel-based methods. So a kernel-based method like support vector machine will give you a concept of a hyperplane, right? Through which you'll be able to classify the data. Now, with this being given, now the next question before all of you is, okay, I know one data set which is on the internet. The data set is called as IoT botnet data set, right? And I'll be able to take the data set. So the data set will look like this, right? Now the data set will look like this. Now what can I do with respect to classifying the data? So here the next question would be is like going back to the coding part and asking what softwares are there in the internet. So there are many softwares. Usually one suggestion would be is like to go for codes which are built on open source. So in that line, what I suggest for you all would be to go with something on Python, right? So Python is a very good software. Reason is it gives you most of the libraries which you want to execute, right? So in line with Python, if you go to the internet, you will find a framework called as Anaconda, right? You'll find a framework called as Anaconda framework. So the advantage of Anaconda framework is you'll be able to combine both Python and R-based programming also and run against the data. So data can be a smaller data, larger data, whatever you have with yourself, right? Now keeping this as information, what we can try to do would be is like how to start executing the programs. Once you system is ready, right? So I can try to say that I can download Anaconda framework, right? So go and download Anaconda framework. Once you go and download Anaconda framework, there what you can try to do would be is like you can try to execute your own programs. So once Anaconda is installed, so in your system you will have something called as Anaconda prompt. So you will get an Anaconda prompt running like this. Now the next question would be is like I need some softwares which can actually be used for analyzing all this malwares. So one set of softwares are for visualization, That means showing some plots like that. There in that line, what you have is something called as matplotlib. There in that line, what you have is something called as matplotlib, right? Okay, matplotlib is one software for visualization part, right? Okay, now the other software that is there is a software called as SEI kitplot. SEI kitplot. Fine. The other software that we have with us is something called as SEI kitplot. Right. Now, many softwares are there in continuation to this, but these two are the main softwares. Once Anaconda is installed, then you will get two editors for you to work. One editor you would get is something called as a Spider, right? And the other editor that you would get here is something called as Jupyter. The other editor you will get here is something called as Jupyter. So one editor you will get a Spider, another editor you will get is something called as a Jupyter here, right? So two editors in front of us, one is called a Spider, and the other editor that we have with us is something called as Jupyter here, right? Now, Spider and Jupyter, they each one of them have their own purpose. For example, if you go to Jupyter, you will be able to run Python notebook files. Python notebook files, fine. If you go to Spider, you will be able to run only Python programs, right? Spider is also possible. So you can either use Jupyter or you can use Spider. What I'm trying to start with for discussion would be like, I'll try to start my discussion with respect to Jupyter first, right? Okay. Now, let's come to the concept of understanding the problems, right? Now, given a data, given a possibility of analyzing the data, how can you go for using the Spider and Jupyter is the next question here, right? Now, we will start with Jupyter. So Jupyter environment is started. It's coming up. Please wait. So we'll have to parallelly open the browser. Yeah, it's getting opened. Right. Okay. Right. Okay. Now this will take you to the environment of starting your Jupyter notebook. Right. Okay. Now your Jupyter notebook is getting started. Right. So it will show you the possible programs that can be running. I've already kept some data set for you to see, right? The same data set and codes will be shared to you also, so don't worry. So I have kept a data set which is already downloaded from the IoT botnet data set. So the data set name is called as dataset model.csv. And I have one more data set also which is called as analysis.csv, right? Okay. So I'm using these two data sets for you to understand the demonstration here. So let's come to the first one, which is going to be k-means, right? Let's come to the first one, which would be k-means here. So I'm interested in running both the algorithms. That is, first I want to run k-means, then I want to run knn here, right? So let's see how the code will look like. The first set of lines of the code will actually show you the packages, right? So here I'm interested in using a CSV file. So I'm saying import CSV. Then follow on to that, I want to use some classifiers. So I'm interested in using a k nearest neighbor classifier, right? And I'm interested in using a k means classifier also. So I got both k-means and also knn classifier running. The next follow on, what I do is I try to load the data set. So the data set I'm loading is something called as analysis data set, which is an IoT data set, which is a botnet attack based data set. Then next is something called as label encoder. What is this label encoder is, if you have some data, right, there is always a challenge with the data. What is the challenge is, now if you look at all these four features, they are all numerical features, right? But there is a possibility for you to say that I have a fifth feature also, right? So the fifth feature as such need not be numerical. It will be only categorical values. Okay, so if I have a categorical feature like this, I will not be able to apply any k-means or knn algorithm because it involves some mathematical comparisons. So each one of you will agree that if you have categorical values, I cannot perform a mathematical operation. There, the need is to convert these categorical values into some form of a numerical value, right? This is done by using the concept of applying a possibility to use label encoders. So what will label encoder will do is, a label encoder will try to convert a data into a categorical data, right? So label encoder is converting your data into a categorical data here. So that's the purpose of label encoder, right? Then after that, what you do is you're trying to run through a k-means algorithm, right? With the k-means algorithm, we are specifying the number of clusters that we want to specify. So number of clusters I'm specifying is 3. So that means I want to classify my data into 3 classes, right? Okay. Now, once it is classified into 3 classes, now our next question would be is like, now the data is now converted like this, right? It is now classified into 3 classes after running through a k-means. Now, when I give a test data, I want to convert associate it to the respective class. Okay. So how do I associate it to a respective class? I can run through a KNN algorithm. So running a KNN algorithm, that's a k alias neighbor algorithm, will associate the class to the class label, and by saying that this is a class based on the knowledge that I've gained from the k-means algorithm, right? Then follow on line code, if you can see here, it will print the number of data. So it is 70 percentage we are using for training, and 30 percentage I'm using it for testing, right? So if I have 100 records, 70 records will be used for training, and 30 records will be used for testing here. Then what I want to print is I want to print the confusion matrix. So the purpose of confusion matrix is when you have classes and when you want to classify the classes, right? You want to know how much amount of classification is correct. So there you can actually show it by using a confusion matrix. So let's see how the confusion matrix comes up, right? So this is your class, right? So let's put our class label. Okay. Let's put our class label here. So our class label is like this. Okay, sorry. So here, now the requirement is we want to understand the classification part. So we are looking at something called as a confusion matrix. So what will the confusion matrix will say is how much amount of classifications is correct. Suppose I look at my class tables to be ABC, that is there are 3 classes here, right? And I want to put my confusion matrix to be a correct confusion matrix. It will look like this. That means class A, 23 instances are classified correctly. Class B, 12 instances are classified correctly. Class C, 11 instances are classified correctly, right? Okay. Now, in case if you are having a problem here in the output, so what might happen is you will not have only values here, you might have values here also. So now what is understanding would be is like a malware signature data which is falling into class A is misclassified as class B. How many records? 11 records. Malware data belonging to class A, 10 records are classified as class C, right? It is called as misclassification. So a classification algorithm can be used there. Let's take you have used k-means with KNN. Somebody will suggest that okay, drop KNN, go for a support vector machine. So when you go for a support vector machine, what might happen is this classification instances will get reduced, right? So what might happen is this might not be 11, this might become 2, so this might become, let's take that 31, right? 32, right? Okay. So the discussion here is like an ideal confusion matrix should not have values other than the diagonals, right? Okay, so we are interested in printing the confusion matrix also here. So the confusion matrix also will be printed as part of the output, right? Then next, what we try to show here is we are trying to show the other plots. The other plots will be the precision recall plot, and next one you'll be interested to show is going to be the accuracy value here, right? Now let's go back here and try running the code. Okay, so 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 let's take the code part here. The code is there for k-means and knn python file. Okay, yeah. So when you try running this code, show you the output. Now, as such, we'll try running the code. When you try running the code, what happens is it is loading the data set. It is running with the k-means algorithm. It is classifying the data with the respect to class label, right? Then it is trying to run with the KNN. KNN will run with the test data, and then it will try to show you the output. So output it is showing is number of records is this, 70% of training data, 30% of testing data is taken, and what is the output that it is predicted. That is after running a KNN, what is the output it is getting with respect to class layer, right? Now, if you come down and see, it will show you the confusion matrix. This is your confusion matrix for your data that you have taken. So this is a malware signature data. This says that these are all ideal classifications, right? And these are all classification results which are incorrect. That means you should use some algorithm wherein you will be able to find out the classification results for all this. That means all this should become zero, right? That's a best example for a ideal confusion matrix. Then if you come down below and see, it will try to show you the plots. One plot that you will see is the plot for the precision where it is plotting the class values, right? The other one that you can find is the recall plot. So these two metrics can be taken here. Okay, one second.
Hello? I think sir got disconnected. Please wait, participants. Hello, participants. Actually, system's got hacked. So he'll be rejoining after 20 minutes maybe. So you can uh, join after 20 minutes or you can wait also, no issues. I think it's better to rejoin after 15 minutes. Thank you.
Yeah, good morning, and very sorry to you all for keeping you in the difficulties. I had a network problem and the system got restarted. Ma'am, can you hear me, ma'am?
Yeah, sir. Okay, you can continue, sir.
Yeah, okay, thank you. Um,
Okay.
okay, so our discussion stopped at a point where we are saying that we have algorithms to solve problems. So when we are using an algorithm for solving a problem, it can be used from a
Sir,
set of
PPT
algorithms.
not visible, sir.
Yeah, I'm sharing the screen, sir. I'm
Okay,
sharing the
okay,
screen.
okay,
Okay.
okay, sir.
Yeah. So as we discussed already in the beginning of the session, if you have a data, the data is available a set of features. This feature speaks about the malware. Now our question would be is like if these features are available, what is the class it can belong? So you can choose an algorithm from unsupervised algorithm, and you can say that it is classified as class label 1, 2 here. This is an example of a two class problem, right? So you can try to conclude saying whether there is an attack or not an attack. Now, when there's a test data being given, if there is no class table to the data, there you can actually choose an algorithm from KNN that can be K nearest neighbor. And using that, you'll be able to predict the data. So this process is called as prediction. Okay, this process is called as prediction, and this process is called as classification. Right? So now we have two keywords with us. One is classification and second is prediction. For classification, we are using k-means, and for prediction, what we are using is k nearest neighbor. Then follow on our discussion was if you have to do the code for all these algorithms, right? How can the code be done? Okay, so there are many approaches for doing the same thing. One way of looking at the problem would be like using k-means and knn, and you can present the confusion matrix. With that, you can conclude whether there's an attack or not an attack, right? So we'll continue on this same line here. So now what we are going to discuss is again back on the code. Okay, first set of algorithms that we had shown to you is algorithms which are based on k-means and knn. Now the second set of algorithms we will look at is algorithm which is very special in the net model category, which is called as boosting classifier. See, it is always important that a data that is needs to be classified will have always outliers. For example, let's take if you look at each one of your data packets that are traveling in the network, whatever packets that are traveling will not be having the same behavior. So there is a possibility for the behavior of the packet to change, and there it leads into something called as an outlier, which is again called as an anomaly here. So the importance of handling anomalies can be focused in two ways. One, you can actually increase the amount of data that you want to classify, and you can say that your classification is improved. Other way of handling the same problem would be is like you can use techniques like sampling, right? And using those techniques also you can come to a conclusion saying that your data has improved a lot. Third way would be is like you people will try to ask you, have you changed the way in which the training and testing has been done? For example, if you've done a training with 70% data and testing for 30%, can you change it as 60-40? Or training can be 75%, testing can be 25%. That's also another solution for you. The last approach that is generally suggested is to go for something called as boosting classifier. In this line of thought, there is a very special classifier in modeling, which is called as ADA boost classifier. Okay. If you go to the internet and type this keyword, ADA boost classifier, you'll get details about ADA boost classifier. Now, the keyword for ADA boost classifier is this says that it is a boosting based classifier. So as the name indicates as boosting, you can try to understand what it will do. And data which is falling as an outlier can sometimes become an inlier when you are trying to use algorithm like Adaboost classifier. So wherever you get a problem that your data set is having lot of outliers, please handle the outliers by using Adaboost classifier, right? So now I'm keeping in front of you the concept of using an Adaboost classifier. Now the next question somebody would ask is, if I want to use an Adaboost classifier and classify the malware attack, is this possible? Yes, it is possible. Now what we will discuss is the code from an Adaboost classifier here. Are you able to see the screen, sir? One of you please acknowledge.
Yes, sir.
Okay. Now, if you can see the code here, the first set of code would speak to you about the required libraries. So here we need k-means for classification, right? And for prediction, we want to use Adabu's classifier here. And the performance metrics that we are trying to evaluate is precision, recall, accuracy here. So you can also show it with the confusion matrix. We have already discussed what is confusion matrix. So what is confusion matrix? It will try to show you all the possible classes and it will show you how much amount of classification is correct. That means along the diagonals you should have values. You should not have values above or below. All these are examples of misclassification, right? Now let's see how an Adabu's classifier can help us. Our understanding was if we use an Adabu's classifier in a malware data set where there are possibility of lot of outliers to come up, our outliers will get reduced. So when you say outliers are getting reduced, it means that when you go to the data set, this misclassification should not come or the misclassification should get decreased, right? Let's see whether your Adabu's classifier does a problem for us. Now, when you come down to this, first step what we do is we load the data. Then we are using k-means. Once we use the k-means algorithm, we'll be able to get the cluster centers, right? Once we get the cluster centers, then the next step before us would be is like we need to start using the algorithms for classification and prediction. So for classifying the data, right, what we are doing is we are trying to use a k-means classifier, and for prediction, what we are trying to use is an Adabu's classifier. So the purpose of Adabu's classifier would be is, as I told you, we want to reduce the number of outliers. That means we want to improve the classification accuracy, right? So let's see the parameters for an Adabu's classifier. The first parameter we will try to provide by default is something called as estimators. Estimators as such is something like where you are trying to formulate the hypothesis against the data. Then the second parameter we will try to supply is the learning rate. We'll come to learning rate and discuss just after this concept. Then next we'll provide the training and testing. Here at this point, I'm keeping an information for all of you. When you are trying to have training and testing, you should have 70% of the data for training and 30% of the data for testing, right? So it means that if you have 100 records which you want to predict, right, you can always assume that 70% of the records can be given for training and 30% of the records can be given for testing, right? Then what happens here is when you run through an Adabu's classifier, it will try to do the prediction because classification is originally done with your k-means classifier, right? Now, if you come down here, right, now it will show you the output. Now, the meaning of the output is the first row of the log, which is taken for prediction, is classified as class label 0, right? Second row of the log, which is taken for prediction, is classified as class label 3. Now, what is this actual output we are trying to indicate here is, if you take the same data, which is given for testing, and run it with k-means, right, it would have shown you a class label. The class label it would have shown would be 0, 3, 1, as it is showing in the output. So it means that this is a output that you're getting from Adabu's classifier. This is the output that you're getting from k-means on the test data, right? Then what we are trying to show would be the confusion matrix, right? We have already discussed about what is confusion matrix, right? Then if you look at your confusion matrix here, now our interpretation would be very clear. An ideal confusion matrix should have values only along the diagonals, but we have some values above the diagonal and below the diagonal. They are all called as outliers. So how will you comment on this? You would say that a log or a data which is originally belonging to class 1 is misclassified as class 4, right? A log or a data belonging to class 2 is misclassified as class 3. How many instances? 744 instances. All these are misclassifications, right? So whatever may be the algorithm that you are using for handling the malware signature analysis, your algorithm should be able to reduce the number of misclassifications. That means you should not have any value above the diagonal nor below the diagonal, right? Okay. Now, if this is a information that we have for us for analyzing, then the next question somebody would ask is something called as a performance metrics. If you want to compare the models, there are many metrics in analysis. One, you can use precision, or you can use recall, or you can use F1 score, or you can use accuracy, right? But make it a point that most of the approaches that you're trying to solve will ask you whether you have tested with something called as accuracy. right? Even for malware attack classification, please use this metric of accuracy to classify whether the attacks are classified correctly or not. Now let's come to the conclusion from here. What is the conclusion here? Here it says that the precision values are 0.39, 0.98, and so on. So what does this mean? An ideal precision value should give you a closer value to 1. But here we are getting only 0.39, 0.98 and all. That means the precision is not good, right? But when you come to the recall, right? Recall as such is giving you good values here. But let's comment on the accuracy. The accuracy you're getting here is 74%. But when you go to your k-means, which we have started right earlier, you would actually see that the accuracy that you're getting will be a little higher, right? The accuracy value is close to around 98% is what is accuracy you'll get here when you're coming to your k-means here. So in conclusion, you will be able to say that I tried classifying my malware attack by using an k-means and knn. I got 98%, but the same thing I'm trying with ADA boost. My accuracy value is 74%, right? But when you look at these two numbers, any one of you will comment that 98% is good. So k-means and knn is perfect. You should not use ADA boost. But the discussion should not go like that. You should always ask a question. In this amount of accuracy that you talk about, how much amount of positive samples have been misclassified? Okay, so when you look at any data, our concern is to worry about the positive samples, right? So your positive sample, right, okay, should not be recognized in an incorrect way after you do the prediction. So the final point I'm keeping for everybody to understand is any algorithm that you choose, as well from my experience, I'm saying it may be k-means, SVM, ADA boost, or any algorithm that you choose should be able to reduce the number of false positives. Okay, so the reduction of false positives is an important part of any malware classification problem, or whatever may be the machine learning algorithm you use, whatever may be the application that you're trying to apply. The ground truth statement is very simple. Have you reduced the number of false positives? Now, at this case, if you ask, let's take, you say that I have two algorithms, right? Okay, let's take here for comparison is ADA boost. I'm using other one is k-means, right? Now, when I ask you a question, which has reduced the number of false positives? If you say ADA boost has reduced the number of false positives, right? But as such, when you come to the case of k-means in ADA boost, with comparison with ADA boost, the false positives have increased, right? Please try to understand here. The false positives have increased. If you say like that, your accuracy factor will become void, right? Because with respect to accuracy, we saw that ADA boost is showing you 73% accuracy, but k-means is showing you 98% accuracy. With accuracy, you will conclude that your malware attack classification, you will have to go to k-means. But when you come to the false positives problem, the false positives are reduced when you're going for ADA boost. So your conclusion should be, from a researcher point of view, to go for ADA boost classification for malware analysis. Okay, this is a real thought process, right? So modeling a problem should not decide just by the numbers. Just I use an algorithm, I got accuracy at 80%, 81%, it's good. No. You will have to go to your positive samples, you will have to go to your negative samples and see how much amount of false positives have occurred. If your false positives have increased in a k-means, but accuracy is high, still in that case, you will go to decide that ADA boost is better. Okay, this is the next information that I am leaving to everybody. Now, this is all at one stage, okay, where you are trying to say that I have malware data and I want to classify my data, attacks are recognized. Okay. Now, at this point, people might ask me a question, okay, is there a way where you can look things differently, right? Okay, there are people are talking about research in different perspectives for malware attack classification. Is there a way to look at a different perspective? I'll show you one. That's the next part of discussion here. Okay. People nowadays are talking about something called as deep learning, right? Can one of you say what is your understanding on deep learning? Participants? Participants, can one of you say what is your understanding on deep learning, please?
Hello, sir.
Yes, madam.
This is regarding the deep learning. We will be having many hidden layers.
Good. Okay, ma'am. Then?
And we will take many parameters to fine tune.
Okay.
and sorry, we won't be knowing the features, whereas in machine learning we will select the features, but in machine learning, in deep learning, it is like a black box. We will give only the data, and automatically it will select the features, and we won't know which feature it's got selected.
Very nice one. Thank you. Thank you for supporting the question discussion. Okay, I think now participants, each one of you got the summary, right? When you're coming to deep learning, we will have something called as hidden layers, right? We will not have anything as features. Sometimes we'll be able to have features available by learning part. That means the deep learning will be able to learn it, right? Okay, that's the thought process. So let's come to the discussion here. Now I'm sharing you the screen for discussion. Now, what we are going to take through in the perspective is, okay, if this data, all this malware data, is going to become larger in size, what is your answer would be? You would say that no, it is no more smaller data, it is a big data, right? So naturally, it cannot be processed by systems, it has to be run on higher computer machines. There you would say that I'm going for something called as a GPU, right? Graphical processing units, right? Okay. The other thing people will say, start saying that is, can I have computers which has higher level processors, right? Okay, so there the answer is we are slowly moving from a system level to a system where there are computations higher possible, right? There you are talking about something called as a cloud model, right? So what would a cloud do here? Cloud as such will give you a solution where your data can be posted to the network and the problems can run on the network. That means whatever algorithms that you've created would be able to run on the network there. Let's take our discussions forward. So here, what we are trying to talk about is how deep learning with malware analysis can coexist with cloud. Are you able to see the screen, participants?
Yes,
Yes,
sir.
sir.
Yeah, okay. Now, a quick comparison as your participant has already told you, we are going for deep learning because we want to go for higher amount of accuracy. When the data is larger, you can go for deep learning, right? You can actually look at data as a set of features. And when given features to deep learning model, it can classify the data. That's a conclusion here. There, the history will always speak that all deep learning models are resembling neural network concept, right? So what does a concept differ here is a deep learning will give you possibilities of having data. Data has been created means you can actually learn the features if you're going for deep learning. Please make a note of this point. You can learn features when you're going for deep learning. Usually people will say that you need a bigger data, there you go for deep learning. The reason is when there is a more amount of data, the learning component that you can make from the data is higher, right? When the data is larger, there is possibility for you to learn more, right? That is the reason people always say that you can actually try to convert a data which is a smaller data to a larger data and see how the data can be modeled by using a deep learning approach here, right? Now let's see some fundamentals for us to understand. This has some fundamentals for us to understand deep learning. First fundamental would be is like forward propagation, backward propagation, gradient descent, and next is perceptron. Now, each one of you, when you have a data for malware analysis, you would say that I'm trying to give it to a model. If your model is going to be a deep learning architecture, there it will say that it is going to have neurons. So the fundamental concept here is like we have something here called as a perceptron. This perceptron is taking some inputs. What are your inputs? X1, X2, X3. Assume that these inputs are going to be values being provided. Let's take the values. X1 is 0, X2 is 1, and X3 is 1. When you add all these three values, you will get 2, which is greater than 0, right? So the output will become 1. Else the output will become 0. So here the conclusion here is like you need a threshold value to finally conclude that the output is either 1 or 0 here. So to make it happen, we will add something called as a bias. So how will your bias as such will come up with? A bias will say y equal to ax plus b. So here the component of b, which is a constant that you provide, can be assumed to be saying that it is going to relate to a bias value here, right? So the next keyword would be is activation function. When you talk about an activation function, the formula would be is a is equal to f of summation of I equal to 0 to n wi xi. What I'm talking is not new. Here x1 into w1, x2 into w2, x3 into w3, right? That means I goes from 1 to 3 here, right? And you are trying to put up saying that it is a summation. So summation of I equal to 0 to n wi xi, right? Now, the next keyword that you have to understand with respect to here is a bias. As far as bias is concerned, how will the bias contribute into the model would be is it would say W1 x1 plus W2 x2 plus W3 x3 plus it is assumed to be 1. That's a constant value as 1 initially. So it is 1 into B, right? Okay. So in this basis, when you talk about this activation function a deep learning model will have more of non-linear activation functions, whereas a machine learning model will have mostly as linear activation functions. This is the other difference for you all to understand, right? When you have non-linear activation functions, your learning component on the data will improve, right? For example, if you ask yourself how much is your learning component, you would say that it is non-linear nowadays. The reason is when you look at a problem, or let's take it's related to maths, you are able to interrelate that problem to computer science, you are able to interrelate the problem to something in chemistry, and you are able to have a learning component, right? So most similar patterns, what you would have learned from maths, computer science, chemistry, together will go together and you will formulate a nice research problem statement, right? So a non-linearity on the model will make you to learn more complexity in the data. Please make a note from the real perspective. So that is why people talk about deep learning. People say that go to deep learning, you will get a lot of non-linear approaches, non-linear kernels with which you will be able to evaluate the data. So the data that we are giving here is a malware data here. Now the next one here for a discussion here is like about the models. This is your neural network representation. You have input neurons, you have hidden layer neurons, and you have an output layer. But see the difference on deep learning, as your participant was saying, a deep learning will have lot of hidden layers. These are all hidden layers here. And see the amount of interconnections. Each hidden layer neuron is interconnected with every other hidden layer neuron. So there is a lot of learning that will happen here, right? Okay, now you know what a hidden layer is. Now, the next important thing is when you go to machine learning, let's say it's a neural network model, right? When you go forward, right, it's a forward propagation. When you go backward, it's a backward propagation. That is what people talk about back propagation based neural network models, right? Okay. Now, when you come to the case of deep learning also, there is a forward propagation, there's a backward propagation, right? Please listen to the discussion. I will try to show you one deep learning architecture for malware classification, right? As a demo also. Now, let's come to the next discussion here. When you come to neural network, when there are weights being provided, right, all weights will be used in every iteration. When you say one epoch, where there's a forward and backward, epoch equal to 1, you say that it is forward, backward, right? Epoch equal to 2, 1 forward, backward. All weights will be used. But when you come to the case of deep learning, it's not like that. When you say one epoch, in the first epoch, all the weights will be used and it will go, it'll come backward, right? Now one epoch is over. When you set the epoch to be, number of epoch to be 2, when it comes to the second epoch, not all the weights will be used in the model. The weights which are relevant to the learning alone will be used. Please understand the difference. The weights that are relevant to the learning alone will be used when you are coming to the case of deep learning. So how does the weights learn? How does the weights adjust themselves? How does the weights lose the connections? Because when you say weights, weights means what? The interconnections between the neurons. How do you say that the weights are not calculated in the second epoch? It is the learning capability of the deep learning model. So a deep learning model will have the capability to say, these are the weights that are required, these are the weights not required. Those weights alone will be participating to the model, right? Now, the next keyword here is when you come to deep learning, you will start seeing keywords as parameters and hyperparameters. What is parameters would be is parameters are one which will be helping you to make the predictions. Hyperparameters are one which will be allowing you to estimate the model parameters, right? Usually when you go to neural network, you will not have anything like hyperparameter at all. But when you come to deep learning, you will have hyperparameter. That's the next learning to all of us, right? Okay. We are saying that deep learning gives you something called as hyperparameters. So the hyperparameters will be set manually. Parameters will not be set manually, right? Okay. And this parameters will be found after training the process. That means the model will run for a lot of time and then give you the final parameters, right? So how can you estimate these parameters is using different optimization algorithms, which can be ADAM, ADAGRAD, gradient descent like that. When you go to the hyperparameter, the choice of hyperparameter will say how efficient your training has happened, right? So when you make a deep learning model, make possibility for you to understand what are your parameters, what are your hyperparameters, right? Because the parameters as such will be learned, hyperparameters need to be provided. Example of hyperparameters is what you can see here called as learning rate, number of epochs, hidden layers, hidden units, and last one is something called as activation functions. Now, I have told you in the beginning of session saying that when you are trying to do a prediction, there is a lot of possibility for you to land into something called as overfitting, right? So the challenge here in overfitting would be something like we are getting a new data in the testing, but we are not able to classify the attack, right? Though we have a training already done. So there it leads into something called as overfitting. Sometimes if you work with a smaller amount of data, you might lead into something called as underfitting also. So your problem should not either be assumed saying that it has overfitting or underfitting, right? So you should be able to look at solutions for handling this. So most of the architectures look at this. One point directly for your learning is I have talked to you on boosting classifier. So a boosting classifier is an approach for you to handle overfitting problems, right? The other approaches would be like you can go for cross validation. What is cross validation is you can actually split your data into two sets. One can be for training, another can be for testing, right? In this, you just split your data into multiple training testing splits. That means if I have 1,000 records, split your 1,000 records into 10 batches. Batch 1 is 100, batch 2 is 100. Each batch individually you split it as training and testing. The next is more amount of training data, right? You can try to increase the data to the model. So there your overfitting problem will be solved. Next is data augmentation. What is data augmentation is how the data is looking at every point of time can be modified, right? So this can always ask a question for the participants, right? Participants will say, how can you make a data look different, right? If you can actually understand the characteristics of the data, you can make the data to be different. For example, what I usually suggest would be like if I have a data for me to classify, right? And the data is having some numerical values as what we have discussed, right? You know very well that this has some characteristics, right? I just show you here. This has some characteristics. So what can be my characteristic? I would say that the maximum value that I might get here is 100. Are you getting? So now if you ask a question, what can be the maximum value? Then somebody would ask, what can be the minimal value that can come for this feature? So the minimal value can be, let's take 10, right? So I have only 3 records. But what I can do is I can generate all possible values between 10 and 100 for this feature, right? Using some probability function, and that can become a bigger data, right? Now, though originally my real data is only 3 records, I might have a larger data with different characteristics, right? This is one way where you can actually do this process of something called as data augmentation. The next is reduction of complexity. What is reduction of complexity? Please reduce the number of parameters that you're using in the model, right? In neural network, you are using 7 parameters. Please try to modify it and say that I'm using only 5 parameters, 4 parameters like that. Last step is people suggest, can you combine classifiers? For example, we said k-means for classification, k-NN for prediction. But somebody would say that, can you use k-means with the fuzzy c-means with k-NN? So people can understand. K-means with fuzzy c-means with k-NN. That means you are combining classifiers. That's an example of something called as ensembling, right? Now, before we step into the deep learning model, let's see how mathematically your neural network model works. Now, this is your data that you want to provide, right? This is your data you want to provide, right? Okay. Now, given the data like this, right, what we are interested in doing is we want to classify the data, right? We want to classify the data. Now, if you want to classify the data, now the challenge is what is your weight and what is your bias, right? Okay. Now, the weight matrix has to be assumed. So people can always assume that the sum of the weights will be 1, right? So if there are W1, W2, W3, so your uniform value of giving in weights would be, it will say that it is 0.3, 0.3, 0.3. Or there are autoencoders through which you can actually generate a weight matrix. So that is a weight matrix that is being generated here. Now the next question is what? Y equal to mx plus b. That's a constant component. That's a bias that is required. So calculate the value for bias. Now this is your input data. This is your weight and this is your bias. So how does it relate to your data? If this is your data, right, you can assume that whatever x value that you're seeing here is this data. Whatever x value that you're seeing here is this data. Now you have something called as your weight. You have something called as your bias. Right? Now the next one that we want to do is we want to calculate the hidden layer input, because you can very well understand that once the data is provided to the input layer, the next layer would be the hidden layer. So we want to calculate the input that we want to give for the hidden layer. So how can it be calculated is take value of x, multiply with WH, add it with B. It's a dot product, right? X into WH plus B. You will get a value that you provided under the hidden layer input. Fine. Now this value of y is the expected class. Please try to understand. We are now trying to do the training part, right? So we are saying this is class 1, this is class 1, this is class 0. First row is class 1, second row is class 1, third row is class 0. For that we are trying to train the model, right? Now when we get a hidden layer input being available, right? Now the hidden layer input values are being provided here. Next, we calculate the hidden layer activation. How is hidden layer activation calculated? Is we have to take the value which is there in the hidden layer input, apply a sigmoid function, right? Sigmoid will actually return the output as 1 by 1 plus exp of minus x, right? So take this, apply sigmoid, whatever you get as a result, please provide it under the hidden layer activation. Now you have values for the hidden layer activation. Now the next question is, what is the output value? Output value can be provided as taking the hidden layer activation multiplied by the W out, right, added with B out. Okay, so your value that you're getting here is 0.79, 0.80, 0.79. Now what is the conclusion? We had given a data like this. We have an expected output. We have weight and bias being provided. In one step forward, it is able to calculate that the output is 0.79, 0.80, 0.79. So the output is supposed to be as 1, 1, 0. So now this set of steps is called as forward propagation. Now the next step what we need to do is we need to know how efficient it has completed the learning. So we find the difference. So we say 1 minus 0.79, 1 minus 0.80, 0 minus 0.79. This will become error here. Okay, so it is 0.2, 0.20 minus 0.79. Now the value is now provided. Now from here what we are trying to do is a backward propagation. Why does it go to the backward propagation? The model has to keep on running until the error value becomes 0. Right? When you say deep learning, people will say how many epochs, 100, 1000, 5000. They will say that it is running for 2-3 days. Why? It wants to minimize the error. When what is the minimal error you want to achieve would be is like 0.000 some value. So you want to run for a certain number of times until this error value becomes 0. Now we have an error value which is greater than 0. What is the error value? 0.21, 0.20 minus 0.79. Minus 0.79. Yeah. Now it goes to the backward propagation. When it goes to the backward propagation, we have already told you in a neural network model, it will take all the weights, right? Now, when it goes to backward propagation, it goes to the next step of calculating the values for the slope output layer, right? And similarly, it will find the slope values with respect to the hidden layer also. Slope output and slope hidden layer, right? Okay. Then next what it does is it tries to compare this values and finds the error at the hidden layer, right? So there's a formula for each of this. Don't worry about that. There's a formula for each of this. We are finding the error at the hidden layer. Parallelly, we'll get something called as delta output. Once we get the delta output, it can be taken forward, right? We can calculate the delta at the hidden layer. I'm trying to show you on the screen to get a feel of how the backward propagation works, right? So we can get the values for the delta at hidden layer. Then we can get the equivalent value for W out, right? Now this W out will change. Can you see here? Because in the backward propagation, the weights are influencing the data again. So the attribution, what is weight? Weight as such is basically a possibility of strengthening the data classification part. So the weight value in the forward propagation was 0.30, 0.25, 0.2923. Now in the backward propagation, it is getting modified as 0.29, 0.25, and 0.23. Right? Okay. Now with this, it finds the bias at the hidden layer. Bias value is already there, right? Then it tries to find out something called as a learning rate. This learning rate is the important part. That means the model that your creator right now has run for one epoch. It has found that the learning rate is 0.1, right? And the error at which it is now completing its 0.21, 0.20 minus 0.79, right? This is for one epoch. When you say second epoch, what happens? Again, it goes with this same input and goes to the second iteration of doing a forward propagation and backward propagation here, right? This is the essence from neural network. Now come from here to CNN, right? Somebody says, I want to use CNN concept. Then people say that, yes, there are neurons, there are layers, but I will call the layers to be hidden layers. So the hidden layers as such will have some special functions. What function they can have? One, it's called as an input layer. That means it takes the input. It has got convolution layer, which will do the dot product operation. It has got ReLU layer, which will actually apply an activation function, right? And it has got pooling layer, which will actually do the downsampling. And the final output that you see on the right will be the fully connected layer. Let's see how it goes forward. Now, the same data that you saw earlier, right? This is my data that I have from my feature matrix. Now, I want to take it to a deep learning model. Now, this data as such is what I want to train, so people can understand. Right? This is a data which I want to train to the model. In deep learning will ask you first question, I can understand only image data. So people ask, can I take some of the data? Yes, you can take. But only thing is you will have to convert that same data which you want to provide as a image model. What is the image principle? Image as such is a square matrix, right? Okay. So at least you should be able to convert this 3 cross 4 into 4 cross 4. So when you want to do like that, simplest way would be like people will say that do some padding. So what will padding will do is padding will try to fill it with zeros. So people might ask, if I'm trying to do padding on the data, will it affect my malware data set? No. Reason is anyway the original information remains the same, right? So the possibility here is first step what you do is you take this data, you have to do a dot product with a filter. Okay, so when you want to do a dot product with a filter, the challenge would be is like the filter will give you a size. Now I'm considering only 4 features. If people have a doubt, I've not taken 5th feature, don't worry. My data has got only 4 features. Now when you do a convolution, what it asks you is what is the filter you're going to consider, right? So let's talk about the understanding here. If you say about filters, there are many filters on the internet. If you go to internet and surf, you'll get a lot of filters. Median filter is there. Gaussian filters is there, right? Okay, there are many filters. Now, let me assume a filter like this. Okay, let me assume a filter like this. So here, I'm just saying 1, 0, 1, 1. This is 0. This is 1. Now, this is my filter, which I want to multiply on this given data. Now, what I'm doing is convolution. Please understand what I'm doing is convolution. Now, what it does is it calculates 1 into 2, 0 into 3, 1 into 4, 1 into 1, 1 into 2, 0 into 3, plus 0 into 1, 1 into 2, plus 1 into 2. You will get one value, right? It resembles to what you are seeing here. This is my data. This is my filter. I multiply. I'll get one single value. That value is the first value of your newly created data, right? Now, this will continue on the entire data set. So now you move this filter over the next 3 cross 3, next 3 cross 3. The final set of values what you got is the result of one convolution operation. Now, when you say the deep learning model is very abstract, reason is the number of hidden layers can increase and the hidden layer at every order can increase. For example, if this is one convolution operation on my malware data, I can say convolution layer equal to 2. That means you will again take this resultant data and again multiply with the weight matrix like this. What will happen? The number of rows will get reduced. For example, if you have a 6 cross 6, you will get a 4 cross 4 in first convolution, right? Now, when you are again giving it to a weight matrix like this, it will go to 2 cross 2, right? So you can increase the number of convolution layers. That's what I'm trying to conclude. The next operation would be a stride operation that you can do on this same malware data set. What is stride is how many pixels you want to move, right? For example, when you say stride equal to 1, it means that you are moving 1 pixel right. For example, I moved the filter first here. Then when I say stride equal to 1, next, next. When you say stride equal to 2, it is 2 pixels right or down. 2 pixels right side or down. Please try to understand. So this is my weight matrix I'm applying. The next time when I want to apply, I can move 2 pixels right. Can you see here? Because stride is 2. Now I can multiply on this. Right? So you can decide how you're going to move the filter, that's your weight matrix, on the input data by fixing the value of stride. The third one is padding, which I told you. You can fill the data with zeros so that the original data is not getting affected. Once all this is done, we can actually try to say that the output is ready to be given to the pooling layer. Now convolution is over. When you give to the pooling layer, what it will do is, whatever result is coming from the convolution layer, it will take every 2 cross 2, it will take the maximum value out of it. The first 2 cross 2, the maximum value is 792, right? The next 2 cross 2, the maximum value is 856. The next 2 cross 2, the maximum value is 913. The next 2 cross 2, the maximum value is 851, right? So the pooling layer will give you a reduced data. I think you can see here. Originally, we have got 4 cross 4. What is the output? We have 2 cross 2. But the information is still preserved. So the pooling layer is the next important layer in CNN where it can preserve the data and it will do dimensionality reduction also. Once this is done, then the next question somebody would ask is, all this is fine. I might get a data of n cross n, right? N can be 10, n can be 20, right? Can you say me what my CNN can actually give me as an output? The answer is like this. Assume that if you are going to have an image, how will your image come up? The image is a RGB image, means it will say it as 32 cross 32 as a size, minimal size, right? It can be 64 by 64 also. So 32 cross 32 as a size for an image. 3 indicates RGB, red, green, and blue. We want to apply 10 filters of size 3 cross 3 cross 3 because it's an RGB image with stride equal to 1 and padding is 0. That means we don't want to do padding at all, right? Now when you give it to the formula, now let's see what the formula says you back. It says that what is W is the first question. What is W here? W as such indicates as 32 because you are trying to have a filter, right? So you are saying W to be 32 here, right? So your input volume is again relating to the size. So there also it is 32. That is W is 32 here. F is the size of the filter. The size of the filter as such is 3 because we are saying 3 cross 3 cross 3 filter. Third is number of padding. We are not doing any padding. So it is 0. What about S? S indicates your number of strides. Here we are specifying stride to be 1. That means every time you will move the filter 1 pixel right or 1 pixel down. When you apply on this, the answer would be like you will have 32 minus 3 plus 0 divided by 1. You will get it as 30. So the understanding is if you have a data of size 32 cross 32 cross 3, right, your output would be 30. Now, people might ask me a question. See, my Excel sheet is not an image. So naturally, my image as such, you cannot assume it to be an RGB value like this. So there, you will have to understand how you have to convert this data, right, into a form like that, right? For example, if you say my size of the data is 100 cross 100, please understand here, my data is 100 cross 100, right? So people might try to say that this 100 cross 100 data is actually what? Is a set of vectors of columns or vectors of rows, right? You can take that as an advantage and you can convert it as a vector data where the vector data will come as n cross order. Order would be what I'm saying. No, here it says 3 here. 3 indicates your RGB values, right? So this is a small shift that you have to do when you come into the malware data or any data which has got an Excel sheet format, right? Now, this is taking you to the next question. Okay, can we do something like this in models? Yes, it is possible. Now, let's come here. When you want to do like this, then you are taking the support of deep learning. That means you have to make use of deep learning architectural frameworks. So if you go to the internet, you will find an architectural framework called as Keras, right? You will find an architectural framework called as Keras. You will find another framework called as TensorFlow, right? You will also find one more framework which is called as Theano. You'll find one more framework which is called as Theano here. So Keras, TensorFlow, you can also use something called as Theano here. Now, each of the frameworks are special in their own way. For example, you can use Keras as a front end. Backend can be either TensorFlow or Theano. So you can use Keras with TensorFlow or Keras with Theano. Other than this, people also suggest some other third-party frameworks which are also there, which is like PyTorch, right? You can use any one of it. It's up to you, right? One suggestion which I usually say to me and my scholars also is, when you start with a problem and a malware attack analysis, and let's take you want to try on a deep learning, surf on the internet on relevant code. You might get one on Keras and TensorFlow. No problem. You take that code and first figure out the architecture that they have used. Then you can improve your results, right? Now, if this is all done, then the next question would be is like, can I do some samples? Before we show you that, let's quickly see this UI, because we have been talking more on the theory part, right? If you see this UI on the internet, TensorFlow Playground, right? TensorFlow Playground. If you click on this UI, it will just show you quickly about the theory of what deep learning is all about. When you look at data, see here, this is a challenge in deep learning. Deep learning says you that you give me any type of data, I can classify, right? See this data. Can somebody look at this and say classification is easy? No. If somebody looks at this data, what they will say? There is two classes visually, one is orange, one is blue, but classification is very hard. So here we need non-linear kernels, right? Here we need more time. We need a better amount of learning. There, deep learning is a solution. At this point, people might ask, why don't I use transfer learning? Yes, transfer learning is also suitable for problems, but transfer learning will ask you one question: is your data small? For example, if I say that I want to do a prediction of fire, people will say that I don't have big fire data and all, because you cannot create fire data. I think people can understand, right? So wherever the data is small, for example, you recently found a new type of attack. It has just come 3 days back. Do you get big logs? No, you will not get it. And you cannot generate that attack. If you generate that attack, it means what? It is a mistake. You are spoiling your own network. So wherever data is small, there people suggest to go for transfer learning, right? Now, given data like this, where there is a difficulty in classifying on the data, please go for deep learning or transfer learning, right? Otherwise, my data is very nice. It can be classified with regression. Please do it with regression itself. Don't come to machine learning. Don't come to deep learning. That's my suggestion to everybody here, right? Now, because sometimes what people do is they do a mistake saying that I know an algorithm, so I'm trying an algorithm. Don't do like that. First, understand your data. If your data really demands a complex algorithm, please choose a complex algorithm, right? Then let's come to the left side. You can see the ratio part. What is ratio here is how much you want to give for training, how much you want to give for testing. The next question would be the noise. How much amount of noise can be provided to the data, right? The third component will be the batch size. Batch size as such will indicate that the size of the data is 100 records, 50 records, or 30 records, right? You can indicate your batch size as you want, right? It is up to you to give your batch size. Now, this is going to be your features. What are your features? All these are features. All these are neurons. You can increase your number of neurons as you want. That's what I told you. This is the other important thing in deep learning. In deep learning, you can increase your hidden layer, right? And every hidden layer, you can have your own number of neurons. At this layer, I can have 3 neurons. At this layer, I can have 2. At this layer, I can have 4. But this is not possible in the case of neural networks, right? And all these are weights. Can you see here? All these are weights and interconnections here. And every time, as I told you in the discussion, it runs in the forward to calculate the error. The error will correspond to the loss. So there'll be two types of loss here. One calling itself as a training loss, another calling itself as a testing loss, right? Now, the next question would be with respect to the values. All these are parameters, right? what is a learning rate, what is activation function, what is a regularization, right? What is a regularization rate, right? This will ask you a question, are you going to take a regression or classification? That's what I told you, whether it can be solved with regression or classification problem. If it is a regression problem, solve with regression. If it is a classification, please go to classification, right? Now, once all this is given, then you can actually try saying the epochs. Usually in the code, you will specify the number of epochs, but this UI, here you are not doing any coding. It's just simulating. Can you see here? Whenever the epochs increases, can you see the classification coming up, right? You can see the changes in the visual appearance. Parallelly, you can see the loss also changing, right? That is why people say that deep learning doesn't have any time limit. It can run for 100 minutes, 1000 minutes, or it can run for a number of days. Final requirement from us is, has it classified my data correctly or not, right? This is just an UI for you to understand what I just spoke to you in theory. So now what you should take from this here is, there's something called as epoch, there is a learning rate, there is an activation function, there is regularization, there's regularization rate. The use of this regularization rate is to handle the vanishing gradient problem when you use deep learning for malware analysis here, right? Okay, now next what we want to see is, we want to see the same thing how it can be done in the code part, right? So to quickly get through the things, what I suggest always is, like, please go through this link on the internet in Keras, in case you're going to use Keras. It will take you to the link like this. In this, it will try to ask you on the developer guides. If you come to the developer guides, you will find something called as a sequential model. Because when you see the code, you should not be surprised. That's what I'm saying this. So what is a sequential model is? A sequential model will try to give you a set of layers where each layer will have one input tensor and one output tensor. Okay. So the sequential model will try to say there are many layers. Layer 1, layer 2, layer 3, like that. Right? Now, the next step that is supposed to be done is, in a sequential model would be is, we have to say the nature of the layers. Layer 1 is going to have ReLU activation function. Layer 2 is having ReLU activation function. So you are supposed to say the characteristic of each of the layers, right? Then after that, what is supposed to be done is, you are supposed to create a sequential model. When you want to create a sequential model, you can specify the layer level characteristic also. When you say the number of layers is 3, for each of the layers, you can specify your characteristics that you want to provide. The characteristics as such are related to what you want to do as an operation. For example, one that people talk about is, are you interested in doing any data augmentation, right? Or are you interested in any doing any sort of a possibility of running through a pre-processing, right? All these are special characteristics that you can do on the code. Now let's see a sample first, then I think our understanding will become better. So we will take through a code which is built on ANN. Yeah, right. Okay. Now this is a code. This is again a Python notebook file. Now what we are doing is, as told already, we are taking the data file. So the file name is data.csv. The file name is data.csv. Then what are we trying to provide is, we are trying to provide the parameters. So the parameters we are trying to provide is, the parameters are basically related to your training and testing. So please see here, you are providing the training and testing parameters, right? Okay. Now, next would be is like the parameters for the model. So please provide the model here. So the model type is sequential model. What is sequential is, we have a set of layers. So at every layer, you can specify what is the dimension. You can say what type of activation function we are trying to have here. So how many layers here we are trying to have is, we have 3 layers here. The next step what we do is, we compile the model, right? So when we compile the model, we need to specify some parameters. So what is this parameters? It is like what I showed you in the UI. We have to say what is the learning rate. If you want to say the regularization part, you can say what is the regularization part, right? You can specify the parameters as part of the code. Now the parameters are specified. Here the most important thing is, we'll specify the type of loss also. There are many type of loss functions. Here we are talking about a 2-class problem, whether it's an attack or not an attack. So here we are specifying it as binary cross entropy. Optimizer, we are specifying the optimizer to be an Adam optimizer. The purpose of optimizer is to estimate the parameters in the model. Once all this is provided, then we try to call the next method called as fit, which will say, what are your data? What is your data here? Data is X comma Y. So this capital X will give you the entire data that we want to feed. So if you have a clarification, it is something like this. You can see here. Data is what we have provided under capital X on the screen, right? Now, the next step, what we are trying to do is we are trying to take the model that we have created. What is the model that we have created here? The model that we have created here is this one. We want to take this model and fit it on the malware data set that we have. So we say model.fit of capital X, comma Y, that's your linear parameters. Then we specify the number of epochs. Epochs is how many times it has to run. Then we specify the batch size, right? So it starts running here. So now whenever it is starting to run, at every epoch, it will try to show you the loss. What is this losses, what you are seeing here? People can have a look here, right? So every time it will try to show you the loss. Here it will try to show you the loss. It will show you the accuracy, right? And this loss is expected to reduce because whenever you are going for one epoch extra, it learns more. So it is 2033, 2082. Now it is increased automatically. Suddenly it is decreasing, right? So the epochs will keep on trying to influence the weights. At the end of it, what happens is it tries to evaluate the model. Now you can try to evaluate the model and check. So now on evaluation with the test data, you can see here with the test data that we have for the malwares. So with the test data, when we check, it is running, it is showing you with an accuracy of 75%, right? So in conclusion, what we are trying to do here is a possibility of using your architecture from deep learning part to influence and see how much amount of malware classification is there. Here, it is using the CNN model. Here, it is trying to classify the data with an accuracy of 75%. Okay, so please understand there is a small thought process people have to get in. Whenever you do a training, right, as far as your deep learning is concerned, it will create you the model. So what will be there in the model? Model will carry the weights. Please understand. At one forward propagation, and here when you are saying that you are trying to create a model, it carries the weights. So from next time onwards, when you want to do the testing, you need not run the model again. That's the advantage of deep learning. One time you run the model and keep it, the same model can be used for the test data for any amount of time because the model file will have the weights. Okay, that's a important thing people should be understanding here. Last, as I told you, here we are talking about metrics like precision, recall, F1 score support, just for everybody to know that all these metrics are possible to be calculated. But which metric is important, you will have to go from your research perspective. When you see your paper, when you see your articles, the articles will say precision is good, recall is good, and they used one algorithm and got a value. With that, you can go and compare and see what is your value that you're getting for the F1 score or precision or for recall, right? This is the one that I want to show for deep learning based. Then next one people talk about is basically a very important architecture called as LSTM, right? I'm getting to completion if people have a doubt. So next architecture which I want to people to understand is this is a very good architecture, right? So when you look at LSTM, LSTM is basically for long sequence data, right? If you have a data as a sequence, there you can call it as a sequential data, and you can say that you can do it with LSTM. So people might ask me, how do you say it is a sequence data? I show you here. This is my data, but it becomes a sequence data when I am trying to introduce one feature here. Please see the feature. What is the feature I'm trying to introduce? Is something called as time. I'm saying 9.1. This is my log. 9.2. This is my log. 9.3. This is my log. 9.4, this is my log, right? So now what happens is at every time interval, whatever I'm getting, right, I can call it as one sequence, 2, 3, 4, 4, 1, 2, 3, 3, right? Each one of it can be taken as a sequence and it can be given to an LSTM. So LSTM is a very powerful architecture. Please, if you're looking at deep learning, please look at LSTM also for your solutions, right? People might try to comment on the RNN part. RNN is also good, but RNN as such, is computationally less faster compared to the LSTM. Okay, I'm again repeating, RNN is computationally less faster compared to the LSTM. So in that point, you can always conclude or say to somebody that I choose LSTM because computation is very fast. Now let's see one for the LSTM part. So when you are doing LSTM, again, when it comes to the code, you have libraries for LSTM. So we will take a code for, yeah, LSTM part. So here there are libraries already there for LSTM. All you're supposed to do is you're supposed to take your data. I'm taking a live data which is in Kaggle. Morning I told you, if you go to type on the internet Kaggle data set malware, you will get your link. I'm trying to use that. So from that, what I need is first I need to get the rules. So here I'm using something called as a decision tree classifier. All of you know what a decision tree does, right? Okay, so it will try to give you the rules for your model, right? So I'm trying to use a decision tree classifier. Once the decision tree classifier runs, what it will be able to do is it will be able to give me the rules in form of features, right? Then after that, what we are trying to see about here is what are the features that are extracted after running decision tree. Please see here, because without knowing the features, you cannot do it. So in this, from the original data, we have taken certain features alone to be important features. All that features alone are being important. Please see here. The features are minor operating system version, checksum, subsystem. All these are examples of features in a malware dataset. What are you seeing? Right? So the original dataset had 55 features. We have extracted the important features alone using a decision tree. So we have taken 18 features. Somebody would ask, why did you choose that 18 features? There is no reason for it. When we run a decision tree, using its own principle, it will say these are the important features. So the important features have been extracted, right? Then after that, what we do is we run through with the model, right? We try to do a scaling here for normalization, right? So now it's a scaled data. What is the reason for scaling? People will know. This is a very important step in pre-processing of any data. Only when the data is normalized, then you can run it with a proper model, and the model also will give you good results. So for all the individual columns, now it is normalized, right? Then when we come down here, next step what we are showing you is how to use an LSTM. So in the code, you will say keras.layers import LSTM. If I want to use GRU architecture, I can say keras.layers import GRU, right? Then we specify the parameters for the code. So if it is a GRU, we need to specify the units, return sequence, what is the shape, all that can be specified, but running the model is same. I think people can understand. Compile, optimizer equal to ADAM, losses, what type of loss, what is the metric that you want to evaluate can be provided here, right? Once all this is done, then your model is ready to be created and the model can work on the data, right? This is a small thought process which I want people to have a look at. And next, last to conclude would be like if people want to work on papers on the similar lines, please go to internet and type KDD malware dataset, right? You will get a lot of papers there. So please take either KDD dataset or there are some modified datasets. You can see here, no, MTA-KDD dataset, right? And next question, somebody would ask, can I learn about all the virus that is there? You will find a website called as Virus Total, right? If you go to internet and type Virus Total, here you will get all type of virus which you are seeing, right? So from the past to present, whatever virus is there will be there. If you want, you can actually go and download the virus, different type of virus and extract the signatures also, right? That's all from my side, and thank you so much for the opportunity being given. Any questions from your side, I'll be happy to answer.
Participants, you can unmute and ask the questions if you have any.
Any questions? I'll
Should I
share my
take
email
the
ID
small
in
question?
chat box. Yeah, please have it for your reference. Um, in this line of thought, what I work is I have PhD scholars working on behavioral security networks, and I have an ongoing funded project from IBM where we look at malware detection in real-time networks. In my general strength area, I work on machine learning and deep learning for video data and network data. So that's my strength. So I have scholars working on video analytics also, right? Uh, so my sincere thanks to Gopalan campus for giving me the opportunity, and my sincere thanks to your principal, Dr. Sengoten sir, and my sincere thanks to Manju ma'am and other faculties who are part of this program who are given the needed support. Any
Thank you
questions?
so much, sir. Thank you so much for such a descriptive session.
Thank you, ma'am.
Yeah,
I've left my email ID. If there's still any more questions, please write a mail. We can always interact. Okay. Thank you
sure.
all. Thank you so
Thank you
much.
so much. Yeah, thank
Thank
you.
you.
Thank you, participants. Afternoon session will start by 1:30. You can join. Thank you.